Okay, for this particular video, we wanted to discuss the question number 2 on the experimental design assignment. And this particular situation differs from the first question because we do not possess a sampling frame. In question number 1, of course, there is a repository, namely the registrar's office, that is going to carry a sampling frame of every Ball State student. However, there is no such sampling frame when we are looking to sample every criminologist teaching at a college university across the United States. Of course, here the scenario says, after reviewing the membership list at the American Society of Criminology and Academy of Criminal Justice Sciences, we recognize that this frame would be insufficient. The reality is that not every criminal justice criminology professor in the United States belong to ASC or ACJS, so they're not going to be a part of those membership lists. So we do not have a sampling frame for our target population. And our target population is such that we are not going to be able to draw any particular sample with any degree of accuracy, meaning it to accurately represent the total population, all criminologists operating in the United States, without a sampling frame. So multi-stage cluster sample is a method which still satisfies the equal probability of sampling method. And is able to get us a workable list in which to gain our sample from. So we're operating with a total population across the United States. So one way to do this through multi-stage cluster sampling would to divide, place each state into 4 regions: the South, West, Midwest, and Northeast. So we have 12 states in the South, 12 states in the West, 13 states in the Midwest, and 13 states in the Northeast. So we then randomly draw, say, 2 states from each region, leaving us with 8 states. That is still too big of a sample of criminologists in which to draw from, or even to create a list from. So within those states, we are going to make a list of every college and university in each of those 8 states. So that list is going to be well into the hundreds, and we then draw, say, 5 universities from each of those states, leaving us a total of 40 universities and colleges. From there, that's somewhat manageable. We can then, with some time, go to each and every website and look at the faculty and create a list of every criminal justice criminology professor within that. That's going to leave us about 500 to 600 criminologists on our list. We can either conduct our survey from there, or if that's too many, we can draw a sample of, say, 200 from that particular list. Every time you draw, though, from each cluster, each sample, you need to do so randomly. And then we are left with, say, a list of, or a sample of about 200 criminologists in which to survey. This method does still satisfy equal probability, because at each stage you are randomly drawing everyone, not to mention the fact that at the beginning of your sampling process, every criminologist had an opportunity to be randomly selected for the particular study or for the particular sample. However, we do run into some problems when we have multi-stage cluster sampling. As we discuss, and as you have read in Chapter 8, every time you sample, no matter if it's random or not, well, we'll talk in context of randomly, you won't necessarily get an exact representativeness of the entire population. And really, in sampling, that's what you want. You want your sample to mirror on every characteristic that of the target population. In this situation, it's criminologists operating in the United States. However, when you sample, that doesn't necessarily happen, and there are slight variations to that. We call that the sampling error. But in multi-stage cluster sampling, you sample several times. In this particular scenario, I think we sampled 3 different times, and it has a cumulative effect. So the sampling error you got basically by randomly sampling 2 states from each region, there's a sampling error there. Then we randomly drew 5 universities from each of those states. That is more sampling error cumulative on the first sampling error. So now whatever sampling you had in your first stage, you will combine that with the sampling error you had in your second stage, and then you will combine the sampling error with your third stage, moving your sample ever farther away from your target population as far as characteristics, especially on the survey, on the responses they give within a particular survey. So we'll talk more about sampling error in the next video, and then of course go over the assignment, which deals with sampling standard error.